My name is Brooke Hepbright. I am the director of CINA here at George Mason University, and we welcome you to our results briefing on the project Graph Analytics, Location Data Analytics, and Visualization for Criminal Network Identification. This project is led by Dr. Dirk Reiners, Associate Professor at the University of Central Florida, Department of Computer Science, and Dr. Carolina Cruz-Nera, the Aguirre Chair Professor at the University of Central Florida in the College of Engineering and Computer Science. Before we get started, I'm going to say a couple of words about CINA for folks who are not familiar with the center. CINA is a DHS Center of Excellence hosted at George Mason University. CINA stands for Criminal Investigations and Network Analysis, and our mandate as a center is to support the Homeland Security enterprise, particularly DHS, in countering transnational organized crime. DHS Centers of Excellence are managed by the DHS Science and Technology Directorate's Office of University Programs, with the goal of conducting groundbreaking research resulting in rigorous, objective knowledge products and timely solutions for DHS components, which is what you're going to hear about today. Specifically, a cooperative agreement means that George Mason University receives annual funding from OUP to fund research by scholars at institutions all over the country, and in several cases in allied countries.
Hello.
Hello.
Hi.
Hi, welcome. We're just introducing the speakers, and we'll get started in just a minute. Please feel free to put yourself on mute. Thanks. The methods in CINA's research portfolio include criminal network analysis, dynamic patterns of criminal activity, forensics, both cyber forensics and traditional forensics, and criminal investigative processes. And today's research largely addresses criminal network analysis. Besides funding and promoting research, CINA's mandate also includes conducting education and workforce development activities. These include an annual engagement with the nonprofit known as ORISE, both funded by DHS, to host summer research teams from minority-serving institutions. We hosted 3 last summer, very excited to host what's likely to be 3 for this summer. And we're in the final stages of selecting those groups. We also are funded to support interns and place them in DHS components. And we're really excited to place our biggest cohort of interns this summer, up to a dozen, largely with our partners at the National Targeting Center under CBP, and at the Cyber Crime Center under ICHSI. If your component is interested in hosting interns, we also place interns off-cycle and would be pleased to talk to you about opportunities. Please just get in touch. CINA also has a mandate to conduct outreach and do scientific education and communications. We have an ongoing distinguished speaker series. We do about 6 events per academic year. Recent events include our January talk from Abby Stiliano at St. Louis University. She spoke about her work on TrafficCam, identifying where victims of human trafficking and child sexual abuse are photographed. And we had a very nice talk from on March 11th from Colton Seal, a former FBI agent and high-value interrogation group leader, now with Pixis Academy, who spoke about interview mindset. We consider those talks to be ongoing professional development opportunities for the HSE workforce. And after professional editing, they're available through our website at CINA with a C, cina.gmu.edu. So please, if you're interested in either of those talks, take a look at our website or get in touch. We'll be happy to send you a link. Upcoming speakers include this one tomorrow on the 26th. Dr. David Mayman of Georgia State University will be interviewed by one of our intern alums and George Mason student, Ethan Burke. They will talk about evidence-based cybercrime research, and Ethan will be disseminating the interview through the Sycamore Institute, the first foreign policy-focused and national security-focused think tank run entirely by college undergraduates. So we're really excited to partner with Ethan, with Sycamore, and to get a new generation of folks interested in CINA's mission and in the HSC workforce. Our final event for the academic year will be on May 6th. Dr. David Kyle from the University of California, Davis will talk about his work on transnational political movements, networks, and human smuggling. He's the author of Transnational Peasants and Global Human Smuggling and the co-developer of the concept of cognitive migration. So very, very topical, we think, and we hope to see you there. Again, you can get information about all of our upcoming events at our mailing list through our website at cina.gmu.edu. CINA is supported by a DHS board of directors, many of whom are on this call. They help us to ensure the relevance of our research and identify champions in funding for transition. In addition to our cooperative agreement, through which the research today is funded, CINA also has a basic ordering agreement recently renewed for 5 years, which can facilitate transfer, licensing, and commercialization. So if you're interested in any of this research and think that it could help your component, our transition and impact manager, Stephen Self, can help set you up. Now, without further ado, I would like to introduce Dr. Dirk Reiners, University of Central Florida, with his talk on graph analytics, location data analytics, and visualization for criminal network and identification. Dirk, please take it away.
All right. Thanks very much, Brooke. Thanks for the introduction. Good morning, everybody. Thanks for your interest in our work, and thanks for your time this morning. As was already said, my name is Dirk Reiners. I'm a professor in the Department for Computer Science at the University of Central Florida, and I've been working with CINA with this project, which is really two projects, for the last 2 years, and we're very, very appreciative of all the work that we've done with CINA, all the connections that CINA has opened up for us, and all the abilities to work on this topic. So, without further ado, what is the topic of our research? Why are we doing this, and why do we think that some of the things that we're doing might, or hope, are helpful for different components inside DHS and inside the general law enforcement enterprise? Our perspective is that it used to be the problem was that people tried to get data and didn't have enough data, didn't have enough information about activities, and not enough information about different people. And that, from what we hear from the people that we talk to and from our personal experience, really has flipped upside down in the last couple of years. Right now, the problem was really more, we have so much data that we don't really know what to do with that. So we have more data than we can really handle. And one of the primary data sources from a criminal network investigation point of view are suspect cell phones and suspect phone usage records and data. From what we've been told by the people that we've talked to that work in this field is that when somebody gets arrested, the first thing everybody does is grab the cell phone, because that's where a lot of data can be, a lot of information can be retrieved. It really is, and we all see that in our own personal cell phone usage, it is a record of our life, and it's a massive treasure trove of data, from simple things like where was I when. Location history is something that is a very important sort of source of data and can help identify activities and can identify a lot of interesting sort of things that people have done without them actually wanting to admit them, just through passive observation of where were they when. Other interactions are there, of course, that make connections between different people. So we have incoming, outgoing calls, we have text messages, we have pictures, We have social media activities. We have Facebook, Instagram, Twitter, all those things that can help us better understand what are the people that this person is talking to. And in the cases where we have multiple of those sort of phone dumps, phone records, we can find connections and we can build the criminal network or identify the criminal pieces of the network, because then that's part of the problem. We all have a social network, and so do criminals. That is not all criminal. So trying to figure out what are the connections that are interesting, what are the connections that are relevant, is one of the core challenges and one of the core components. How do we pick sort of the gold nuggets out of this large treasure trove of data? And we don't always have to have the phone sort of physically in custody. A lot of these information, maybe with some somewhat limited resolution, limited precision, can also be acquired from phone companies directly. So there's different ways to get this kind of data. But the problem is always the same. How do we filter out the parts that are relevant, that are important? How do we aggregate the data that is interesting, that we need to put together? Because then, from what I understand, typical timeframes that we're looking at is 3 months. 3 months is sort of a typical dump of data. And if you think about what you do in 3 months' time, yeah, there's a lot of activities that are probably not relevant to a criminal investigation, but they're still there. They need to be found, identified, and we need to remove those unimportant parts. And there's lots of activities in this field, fair amount funded through CINA, and trying to automate this process, trying to use AI and other data mining technologies to do some of this automatically. But the problem with AI is that it cannot usually find everything. It can find what it's trained for, but sometimes or often we don't really know what we're looking for. So we need to depend on the intuition of the experienced investigator to identify parts that are interesting. But he or she still needs to be able to find those inside the data. And of course, there's always the question of trust. I'm one of a dying breed. I'm a bit of an AI skeptic, but I would prefer having a person make final decisions whether something is suspicious and something needs to be prosecuted or not. So that also means that the person needs to understand the data and needs to have something that really matters and shows them what's going on, even if we use AI or other tools to identify potentially interesting pieces. So what we're interested in, and what was the goal of our project, is to provide visualization methods to better understand and analyze the data, and do it in a way that hopefully integrates into existing tools, because there are already quite a few tools that are being used to do data analysis, and we don't want to start from scratch. We want to be able to integrate as much as we can. So the data that we're targeting in our project are two different data. One is location history. So we're looking at data that is just position on the Earth and the timestamp. And the second kind of data are call connection records or other events that are related to connections between people. There's clearly differences between them, but there are also some common challenges. One is the amount of data. Typically, we have a fairly large number of elements in there. We look at several months of locations. Typically, locations are on a 15-minute interval, sometimes shorter, sometimes longer, depending on network quality. But that's quite a lot of data. And same with calls. And text messages and calls are fairly long and happen fairly often. So for both of these different kinds of data, we use different approaches. And some of this has evolved from and continuing some previous work that we've done with HSI Phoenix and Sandia National Labs. So we've been working with Sandia and HSI Phoenix before we started working with CINA. And that's a good sort of relationship for us, because Sandia is I don't know who here is working with Sandia. Sandia is fairly active in different kinds of analytics with or without AI, but they don't do a lot of visualization. They have fairly simple user interfaces and fairly simple outputs. So that's why we integrated well with them. Also, they had some ongoing projects with HSI Phoenix, so that was always a good sort of sounding board to see if what we were doing makes sense and if this relates to what people in the field actually need. So that was a route to get analyst input, and also that's sort of part of our goal and part of our hope to get some of our tools into analyst hands. So to do that, we needed to integrate with Sandia's tool sets so that they can sort of bundle it and put it all together, which turned out through the course of this project to be a bit of a moving target, and we're going to talk a little more about that later. So what did we do or what have we done? So really, location data is what you expect it to be. We have recorded at varying frequency, as I said, depending on network quality, sometimes 15-minute intervals, sometimes shorter, sometimes longer, but for a long time. So we're looking at several months of data. And what's the challenge with location data is that there's a lot of data that's really not all that interesting. If you think about it, if you drive from home to work, yes, there's going to be a fair number of location samples just driving from A to B that really are not that interesting. So trying to identify parts of the data that are not as interesting that we can exclude from analysis is an important aspect. And what we were interested in also for the context of CINA is what can we do to combine data from multiple people? Can we use this to identify meeting locations? Can we use this to identify points where they did spend time together and hopefully find some patterns on how these meetings go and where they all fit together? So the approaches that we followed here is one of the first things that we had to do that was pretty obvious to do is we needed to figure out how do we identify the samples that matter. So we have an analysis about what elements and what data sequences are really transitory. It's just going from A to B without stopping in the middle, without doing anything interesting. Then the next step is how do we identify areas that are frequent sort of locations for this person, do some clustering analysis to identify parts that really are repetitive and not just I went to buy some scissors in the store just once. So I have samples there, but it's really not something that I do on a regular basis. It's not something that's really interesting. And then, of course, the question is, how do I put more data into my visual analytics, into my visualization, so that I can better understand what the data represents and what's in there. For the networks, we have a couple of different approaches. Really, it's all about connections over time. And that's something that typical network visualization tools don't do as well. They all assume that the networks are pretty static. The time aspect is something that is important in here. That is something that we looked into and tried to find different ways of how to handle that. In addition to that, as we worked with Sandia, they had their own internal analytics to identify what they call three-way context. Essentially, if A calls B and within a certain time frame B calls C, they identify that as one event that might be relevant, and they were interested in a visualization system that can help them understand those better. So we have both of those here. In addition to that, we have a whole bunch of different visualization approaches and visualization methods for different aspects of the data. So we have some examples here of different kind of networks, different kinds of transactions. One of my sort of pet peeves when I do teach information visualization, and one of my pet peeves is that everybody uses the same 5 standard visualizations that we all know that are relevant and important, but are not really very effective for specific kinds of data. My sort of mantra is that there is a point for custom visualization and there is a point in developing customized visualization, because then you can put a lot more specific information about the data in here. And that allows you to be much more effective than just putting one more bar chart or one more pie chart on your screen. All right, so because it's all visual, I would like to show some examples because it's much easier to explain through examples. So the first example that I would like to start with is just looking at some graph visualizations. So this is data that we got from Sandia, essentially the nodes their internal data, they have names associated with them, which they did not share with us. All the data that I'm showing here is generated. So it's not based on real data, because CINA does not allow us to get real data from DHS. So all of the data here is artificially generated. So that's, as a consequence, some of the sort of collections or connections that you would expect to find in real data are not really in here, because we just generated it as best as we could. Here an example, connections between different people. Nodes are people, and each one of those people can have different kind of attributes associated with them, which are represented with the little icon. So here we have a little bit of an overview. So this person has 41 events that are associated with this callout icon. We have the ability to filter, so we can look at only the ones that have this callout, or only the ones that don't have this. So there's interactive filtering methods here. We can move these nodes around. We can do zooms in it and explore this graph as needed. We have a bunch of different layout algorithms. Depending on the nature of the data, different algorithms perform better. And the goal is to do something that allows you to interactively explore the data. We don't assume that we can automatically identify everything that's interesting. The goal is to have something that makes it possible to interactively explore the data and then find connections that are interesting, find connections that are valuable, and then go back into the raw data and identify sort of the meaning and identify what's behind certain patterns that we see in the graphs that we might not see in the raw data. As I mentioned, this is all with time-based, so we have a time slider at the bottom where we can essentially build a time window that we're interested in. You can see most of the events here happen towards the later parts of the time window. And we can manipulate this interactively to see in which time window which connections are active. Like this person in the middle that looks like he's sort of really super active, but he's only active in a very small time window. So before that and after that, there's really nothing going on with him or her. So that may or may not be relevant for certain investigations. The goal is to have something that allows you to interactively explore the data. And as you can see, this is all web-based, so this works anywhere. We're using, to some extent, and off-the-shelf libraries to build this and extend those to get us the new results together. But we're really trying to make this easy to deploy and easy to access. So this is part one. Part two, this is the timeline visualization. This one really, I cannot really say very much about it because this is mostly based on the Sandia analytics. So this is really based around these triple events where we have a source, an intermediate, and then a destination with certain time window in there. So some have shorter time windows, some are longer, and there is some meaning that they didn't tell us about. So again, this is data that we made up. But this is an example for sort of a custom visualization that we did specifically for an analytics tool that they had already. And then just on the side, this is another way to visualize connections between people. In this case, the number of people is relatively small. It's just 7 people here, but they have lots of different connections, and there's different combinations of connections. So that's what all these different graphs are. So we have some events that have 2 people that came together, in this case, these 2 people here. And there are other events that bring multiple people together, and we're trying to find ways to visualize all the different possible combinations and to see where do we have multiple events that have the same combinations of people, and which combinations, and 7 people, you have a lot of possible combinations, are less common, which are more rare. And when do we have combinations of more than 2 or 3 people, then it gets really interesting. How do we lay this out? And that's really what this is about. The other part, the fundamental different part, is the location data. So here, This is an example. This data is actually real. We try to generate this, but if you generate this, you don't get anything useful or usable. So this is actually my data. So this is 3 months of my life 10 years ago. So I don't mind sort of using that for examples and sharing this. So I clearly traveled around a bit, but the center of activity was Little Rock, Arkansas at the time. And you already see what the problem is, that this is just too dense and too messy, and it's really difficult to identify anything useful in this kind of spaghetti diagram. And this is typically when you look at visualizations of phone traffic data, this is the kind of visualization that most existing systems will give you. So, and this is where we started from. So first thing, the connections are nice, but really showing them all the time is just not efficient. So we rather opted to show them dynamically. So when you mouse over different samples, it will show you 15, 30 minutes before and after. So we can see where I'm coming from and where I'm going to after going to this location. So that gives us some idea and some overview. One thing that this sort of raw sample view doesn't show very well is the density. Because this looks like, yeah, this part is a little more dense than some of the others, but it's really hard to tell what are the most important parts. So that's where the clustering comes in. Once we build clusters in different areas and show how many samples there are, how many times I spend time here, it's clear this is an important part, obviously. This is another important part. And there are some other parts that have hundreds of samples in the same area that, of course, show that this is an important part. And then when I zoom in, again, everything is interactive. We can see that this is really a cluster that sort of spreads out into many different areas. This obviously was our home at the time, so I spend time around the home. And plus, phone location data is not always that exact. So there's some spread, some irregularities, or some uncertainties in here that all go together. But again, the main point is being able to do all of this interactively for fairly sizable data. And you can see that this has on the order of 10, 11,000 records that are analyzed pretty much live inside a web browser. So that is one of the things that we do. As background, we're software engineers, we're software architects, and we're very interested in building systems that can manipulate data effectively and interactively. We're really all about interaction. So other things that we did here, other things that we can do. One of the questions, of course, is we have lots of these samples. When do people spend time in these locations? So we came up with this, what we call clock wedge visualization, which is really like a 24-hour clock. So the top is daytime, so from 6 a.m. to 6 p.m. and then the bottom is nighttime from 6 p.m. to 6 a.m. So you can see this location, I do spend more time at night here than during the day, which, given that it's my home, is not too surprising. And then there's other locations here that have large circles that I spend a fair amount of time in, but typically during the day, maybe sometimes a little before, a little after. This typically is, as you can see, is somewhere in the middle of the day, so around noon, or sometimes in the evening. So yeah, this is a mall where we spend time to have lunch or dinner sometimes. So we are looking at different ways of visualizing information to give you a quick overview of the data that's in here. And we also do some more analytical things, looking at travel patterns and seeing from here, where do I go? Do I go to specific places on a regular basis or not? What are the places that I do travel a lot? What are the places that I spend more time at? So we're trying to do a lot of these sort of visualizations and analytics interactively and interactively explorable. So this was my university, so that's where I obviously spend a lot of time and often went to and fro from there. Last but not least, as I mentioned, what we're interested in is overlaps between different people. So here's a different data set. Again, just 3 months out of my life, just time shifted so that it overlaps with the first one. And we can put multiple people into the same visualization, and it still maintains the interactivity fairly nicely. And of course, what we're really interested in is what's the overlap? What are sort of times and places, excuse me, where these two people spend time together? And as you can see, there are some circles in here that show that, okay, here in this area, there's a fair amount of time that these two people spend together. And we can control how picky the system is. Do we want them to be within 5 minutes? Or is it okay if they come within an hour of each other? Or do we just look at infinite amounts of time, just places that they both have gone to? This, of course, is the most, but it depends on what kind of interactions we're expecting. So here in the 30-minute window, we do have a couple that bring overlap. If we go down and say, okay, we want them to be together in 10 minutes, then some of those samples disappear, and we can only see some of them. All right, so in addition to that, we have sort of different views, different map styles, nothing too sort of unusual here. So this is all based on, this is actually based on Esri's map tile server. I know DHS uses Esri ArcGIS for a lot of their map visualizations. That's why we picked this one as the example. So these were sort of the demos. One of the questions that is always asked, how do we transfer this out? How do we make this available? As I mentioned, originally we developed these things to integrate into SNDS software frameworks. Over time, they switched some of them. Originally, the locations were developed for a system called Snipe that they deployed. The networks came a little later in a different project from a SNDS side for a framework they call the CINA. So the goal was to have something that is easy to disseminate to DHS and the HSI Phoenix. But of course, for somebody like, I'm assuming most of the people on this call here are not part of the HSI Phoenix, unless you're working already with Sandia, it's not that easy to get that. And to make that a little more sort of effective, one of the latest or last activities that we did in the CINA project is trying to see if we can make this available in a standalone fashion. So essentially, we developed our own framework for putting all these visualizations together, and that's what you were looking at earlier. This is not dependent on NDHS or Sandia software, so this is all ours. And we're hoping to make this available through CINA to anybody who's interested in it. And of course, really the goal is to make it available in a way that you can put some of your actual data into it. Because then, as I mentioned, a lot of these visualizations, they live and die with having real data. And we were very appreciative to the input that the HSI Phoenix guys could give us. But of course, we couldn't see the real data. So there's always a little communication sort of loss in there. So to do that, we have data importers that use standard and fairly simple formats. So for the locations, we use the Google Takeout format, which is essentially JSON with a list of positions and timestamps, fairly simple. Timeline also is a simple format. We're not quite done yet to make it as easy to deploy as I would like it. Right now, you have to have a little bit of installation to make it run on the system. So you need to install Python and NPM, which are standard tools. Nothing unusual here. This is all standard components. But really our goal is, and I'm hoping I can, even though CINA has concluded, I can find some time to have one of my people work on it and putting it all together into just a single Docker image that you can just run as is and use as is without having to install complicated things. It's just download one thing, run it, and be able to import data and try it. So that concludes my presentation, and I think I went a little over time. But the questions that I have, or what I would be curious about, given that I have a nice group of experts in this field. Do you see a potential for using this kind of visual or similar approaches in your work, in your specific case? And as I said, the things that I showed, I can make them available, that they can run wherever fairly easily. And sort of, as I said, the important question is it possible to test it with your data and see if it works, or what needs to be changed to make it more usable? And then, of course, is this something that would fit with the data that you have? And if not, if you have any other kind of data that you say we have a lot of data that we're trying to explore, and the tools that we have don't give us what we need, talk to me. We'll be happy to come up with new visualizations, because that's really what we do. That's what we like to do. Thanks everybody. Thanks for your time, and I'm open for questions.
Dirk, thank you very much. Very interesting presentation on completed mature research, which we are really eager to transition to DHS components, as Dirk mentioned. Let's see, we don't have anything in the chat yet. Folks are welcome to type questions in the chat, and I'd be happy to read them out for Dirk. We have 36 people on the line, which is a nice turnout for a technical presentation. But I think it's small enough that folks can raise their hands if they'd like as well. Okay, if we don't have any immediate questions, I'm going to kick off with one. Oh, did we get somebody? Yeah, please go ahead.
Yeah, how are you? Sorry, I didn't raise my hand, but I was first of all, I was super impressed because the two logos on the cover page were UCF and George Mason. I have two kids in college. One is at George Mason and one's at UCF. So it's insane.
What a coincidence.
So the question for you, Dirk, actually, I'm with DHS HQ. I support S&T, building out the labs, etc. So it's not directly related to what you guys are doing. But just a question that just comes to mind. The data that you request, obviously from the cell phone companies, from the service providers, what fidelity can you get with that data? So you're overlapping, you're showing, for example, the clusters or tracking time spent at a location. Do you have how often, like when you ping a record or trying to generate a record, can a record be 10 seconds apart, 10 minutes apart? How much data can you get from the providers?
The phone companies, that I'll probably have to refer to the HSI people, because that's the data that they get. We don't get that data. The data that I showed was actually from Google Takeout. If you have an Android phone and you have not explicitly disabled it, Google will store where you've been from the moment you turn on the phone until you turn it off. So if you go to Google Takeout, if you have not gone, I recommend just go to Google Takeout and see what they know about you, and maybe turn some of those off, which I did after I learned what they have. But the location data that they have varies. In some cases, they have locations every 30 seconds. Sometimes, depending, like as you saw on my graph, I was driving to Chicago. There it was more up to like every 10, 20 minutes or so, if you're in the middle of nowhere in the Midwest. The data that I showed, we essentially resampled to a 15-minute interval to make it more manageable, because every 30 seconds is just very, very dense. And then you don't get new information out of it. And in 30 seconds, I don't move any sort of appreciable difference. But so the phone records up to every 30 seconds is the fastest we found. The phone companies, because they only get data from the base stations. So if you don't have the phone, if you cannot dump the phone or cannot access the location history of the phone, they only get data that's a couple minutes. I think, if I remember right, best case every 5 minutes, but they don't get exact locations. They only get, I was connected to the cell tower, which is here, but I don't know where in this several hundred-yard cell this person was. So the cell locations from the phone companies directly are not as precise. For the real location, you need to have a dump.
Okay. Okay. Awesome.
And,
Awesome.
Ziad, just as a reminder, Dirk, and for everybody else on the call, Dirk mentioned this very briefly, but the terms of the cooperative agreement between S&T and CINA and our subgrantees preclude any exchange of real data. And that's for very good reasons. We don't want any confusion about whether researchers are engaged in law enforcement activities. But it does mean that all of our research under the cooperative agreement has to be conducted with either publicly available information or synthetic data. And so I think this project has done a fantastic job of leveraging what's available. And the key to transition is getting the techniques and the algorithms over the fence so that folks at the components can actually try this out with real data and tell us what's working, what isn't. And we have a contract vehicle which can make it very easy for components to to test this out and work with the researchers on a contract basis, which does allow some data exchange.
Awesome. Thank you. Thank you both.
Thank you. I saw there was a question from Ram. What technologies are used to develop UI widgets? So for the actual UI, like all the stuff that you could click, all the menus and stuff, for this one, we use React because that's what Sandia was using to integrate. We used React as a basis. We're also using Angular in other projects, so we're pretty agnostic on that one. For the actual visualization, for the visuals, we use a variety of tools. So we use whatever is the best breed that we can find. For the graphs, we use Cytoscape with some extensions that we develop ourselves to make it sometimes a little more responsive. The maps, as I said, uses ArcGIS, Esri, with the visualizations on the maps are using Twitter StackGL stack, which is a very nice high-performance stack for large data. And as I mentioned, we're really interested in working with large data. That's really something that we're highly interested in. How can we interactively explore large data? And you saw the location one data set had about 10,000, 15,000 records, which from a large big data perspective is really not much. From a JavaScript web browser perspective, can start to be kind of limiting and chunky. So we're also interested in technologies on how to use web browsers more effectively. We have some experiments on how to use GPUs from a web browser, so you don't have to use JavaScript to do a lot of processing. So lots of things that we're interested in, how to make this work effectively in an easy to use, easy to deploy fashion.
Thank you very much. I have one more question regarding the graph analytics. Just wanted to find out different algorithms that you use to build this tool in the backend, and where do you store the graph? Are you using any open source tools to store this graph?
For this specific project, the backend really doesn't do much here. So because it's all interactive, it's all done in the front end using Cytoscape. The backend is just a simple SQLite database just to store the graph connections. We have used other tools in other projects. We use Python for most of our backends because it's effective. So we use NetworkX as a graph processing library in the backend, and that has worked pretty well for us. We're pretty happy with that one. So that's if we have to do another sort of more complex graph analytics tasks that don't work in the front end. And front end has limitations. As I said, JavaScript is not the fastest language. So for that, we'll probably use something like that. We've also done some experiments with large graph databases that we tried, but sort of our experience for interactive exploration, most of the graph databases that we've tried are just not responsive enough. So queries take a couple seconds, even if it's not a very big graph. So for interaction, I need something that is faster. So that's why for most of the projects that we've done here, we decided not to use a big graph database in the backend because the data that we had wasn't big enough to require it, and the overhead that they bring with them didn't make it very amenable for interactive exploration. And if you have a very large graph, we probably have to do something like that. And we will probably have to figure out some of our own methods on how to make it interactive. But this one right here doesn't do pretty much any of that.
Yeah, thank you.
Thank you.
Great, we welcome more questions. I have a question. So, Dirk, tell us about how scalable the visualizations
are. So you saw some of the, like you saw the network, the location visualization. It works fine with 10,000 records because it's really simple and we're only showing points. And as I said, the DeckGL stack that we're using scales pretty well because it uses effective graphics hardware underneath. Some of the other things like the networks, they do have some limitations, especially the layout calculation gets kind of slow sometimes. So really, so what we're interested in, and that's sort of a follow-up that we're starting to look into, is to use GPU-based techniques to accelerate a lot of these visualizations and calculations. So we have some prototypes that give us a pretty good like factor of 20 to 50 speed up for some of these operations by essentially offloading all the work onto the GPU and just using it there, which is a fairly recent development that web browsers allow to do that. And that's certainly a future area that we're interested in exploring.
Great. There is any questions for folks out in Chatland? Look at the chat. Okay, we have a question from Kalpana, asking whether we can get the S&T links for the documentation on architectures, use cases, and prototypes for the presentation. Is this working on Maple environment? So we can certainly put you in touch with the team for documentation on architectures, use cases, and prototypes. We'd be happy to do that. Kalpana, if you wouldn't mind just popping your email address into the chat, we'll have our tech transfer lead follow up with you. And the question about the Maple environment, I actually don't know what Maple is. Do you, Dirk?
No, I don't either. So unfortunately, I probably have to answer that no because I don't know what it is. So I'm pretty sure it's not working on that.
Kalpana, do you want to pop on voice and tell us more about that? Maybe he's not able to use his microphone. That's okay. Okay, so Kalpana,
follow up later.
Yeah, Kalpana, we'd be happy to follow up with you with the documentation. And that's available to everybody with a .gov address. A reminder that CINA research under the cooperative agreement, the U.S. government retains a non-exclusive use rights to all of the research. And so this is your research. You have already bought it. So we are really just eager to give it to you and to make it as useful to folks in the components as we possibly can. So we're strongly incentivized by S&T, frankly, to show progress and transition and to follow up with components to make sure things are working. So we are really eager to work with you on that. There we go. Maple, yeah. Okay, so Maple is the multi-cloud environment with GPUs. Okay, got it. Okay, so we have another question from Rama. Please do share technical documentation to me as we will certainly do that, Ram. Okay, another question from me. So Dirk, how long would it take to add a different data import to get a different kind of data ingested?
Data import typically is pretty simple because we just need to extract the data and put it into our internal sort of framework. That's a pretty quick thing to do. That usually takes a couple of days, 2-3 days, typically, once we have a documentation what the data sort of file looks like or what the data structure looks like. If there's a complicated database behind it, maybe a little longer, but the data input usually is pretty quick. So if you have data that you say, okay, this is almost something that I think would work here, and this is a description of what the file looks like, we can do that pretty quickly.
Great. Got y'all getting questions in chat land? Okay. Dirk, one last question from me then. How long would it take to create a new visualization for a completely different kind of data?
No, that's the interesting question. That of course takes longer. But it also depends on what the data specifically is. And some of the examples that I showed a few pictures. Typically, we can prototype something sort of relatively quickly, but then it's a very iterative process on trying to understand what's important about the data, how does it all fit together. So typically, we have something baseline visible within a few weeks, like 2 weeks or so is typically a good time to start seeing pictures. But then it iterates. Sort of the results that we showed here is certainly not what we started with. So there's a lot of discussion and back and forth to make sure we extract what's important and we give access, interactive access in a way that's natural and easy to use for the end user, because then the people in the end, it only matters if the end user can find what they're looking for. So that's the goal always. How do we make it easily accessible to whoever needs to get it? And that can take a little longer.
Great. Thank you very much. Any other questions from the chat? Okay, Dirk. Well, I think this has been a fantastic briefing. We have loved working with you, and we're really eager to move on to the next step and to introduce you to some of the folks who have have expressed interest today. We've done this throughout your project, kind of following up on interest from folks. Okay, we got another request from Gabriel Martinez. We will definitely send you information. And of course, we follow up with everybody who attends these briefings to share the basic slides and the recording. And so what we'll do with the folks who've expressed interest is we'll talk to you about perhaps setting up a bespoke briefing or providing that more detailed documentation so you can explore transition. So with that, Dirk, thank you very much. We've loved working with you and look forward to the next step. And to everybody who joined us today, thank you very much for your interest in CINA and in our research. Have a great day.
Thanks, everybody. Have a good day.
Bye.
Thank you.
Bye.